They said H, this is number 9. I didn't have the years, right? But it's just the number 9 questions are what we're going to look at, right? The parts that involve circle theorems, circle geometry, right? So H, J, K, and L and M are points on the circumference of a circle with center O, right? Everybody seen all 5 points are on the circumference. Everybody clear there? MK is the diameter, right? M to K would be the diameter of the circle, and it is parallel to HJ. HJ is here, right? MJ and MJ, where MJ is? MJ is equal to LJ. That's why they have these slashes on them, because they are equal. And angle JMK is equal to 38 degrees. That's the only angle they gave us, right? So, explain given a reason why HJM is 38 degrees, right? So, let's locate H to J to M. That's this angle here. Everybody seen that? So, they want us to explain why this angle is 38 degrees, right? These angles are what we call alternate angles, right? You all see the pair of parallel lines? Let me kind of repeat it on the side here. 1, 2. That's a pair of parallel lines, right? Once we have a line going this way, boom. This angle underneath here, which is A, is equal to this angle up here, which is B. And they are called alternate angles. Right? Are equal. Talk to my bro. Any drawing? Right. So let me highlight in red the parallel line. So you see in this line here, big bro? That's one parallel line, right? Okay, this is where you have to decipher. This is your brain, right? Then let's put our next parallel line here, right? Watch it. Bang. You see the arrows on the lines? These are the parallel lines, right? And let me draw the line, which is this line coming on here. Watch it. Right. You see the transversal, a line going from one parallel line to the next. So the angle on the bottom here is like A, and the angle up here is like B. So it's like not all the time the parallel lines going to come so. They might be so, they might be so, it might be better, right? So we're going to write so write this to me. This is part 1. So, they want to explain, given a reason why this angle is equal to this, right? So, HJM is equal to 38 degrees because, yes, alternate angles are equal, right? So basically, watch it, I'll go back up. So this angle here, let's say this is A. This is equal to this angle up here, this is B. You see A and B, they are alternate angles, right? So JMK. So it's like JMK is equal to HJM. Are we good there, my children? Right, so we're working with MJK. So let me locate M to J to K, right? So M to J to K. So I'm gonna draw one more line here. All right, boom. And I want to remove this line up here because we're focusing on the red triangle now, right? So everybody focus on the red triangle. You all seen that? Go to the notes that I gave you last day. You will see a note which says angle in a semicircle is 90 degrees. See for the see now. Angle in a semicircle is 90 degrees. It's basically when you have a diameter. Right, excellent. So the angle formed of the diameter is 90 degrees. Okay? Once you have a diameter, which is a straight line that goes through the center of your circle, right? And it touches the circumference on either side, the triangle that we form of the diameter, once this top here touches the circumference, it is a 90-degree triangle, right? So, what's that? The vertices. Right. So the top vertex here must be touching the circumference. So you see a diameter triangle formed of the diameter is called a right angle triangle, but the law uses angle. So the reason for this will be angle in a semicircle. So write this down, please. Angle in a semicircle. Press it. In a semicircle is 90 degrees. That is the law. Everybody good there? That is the law. Right? Anytime I have a circle here, boom. And I have a diameter. Let me call this that. Let me see if this diameter coming this way. Once I form a triangle of this diameter, watch it. Bang. Chili, chili, bang, bang. You see that triangle? What is the angle in this triangle here? 90. Simple as that, right? Dog food we call this. Rolling on to the next question. They said determine the value of each of the following angles. Show detailed workings where appropriate. So let's locate angle MLG. Right? There we go. Angle M. So you're starting at M, you're going to L, and you're going to G. So look at here. You all see that? M to L to G is this angle here. Now, how are we going to find this angle? Let me hear all the ideas. Anybody? Are we seeing that these two angles are equal here? That's one. These two lines, sorry. This line, you see this stroke? And this stroke here, it means that these two lines are equal. Let me move this. Right, that's all. Let me move this. No, I'm going right. So I'm going to move the red here. Right. So I'm going to draw a line here to show the two lines are focusing on. You all see these slashes on these two lines? Right. It means that these two lines are equal. The three angles of, we're not really using these two straight lines, I mean these two equal lines here yet, right? We have here as 38, we had here as 90. What this angle down here would be? The three angles in a triangle add up to what? 180, right? So, focusing on the triangle we were focusing on before, I can find angle MKL. Cool? So, let me go down. So, we go down. We're going to find angle MKL. So, MKL is equal to 180 minus 90 plus 30. Somebody work out that for me. What is MKL? Let me just highlight the... Right. That's how I highlighted. This is the triangle we're looking at, my children. Watch it. Right. So this is the triangle we're focusing on. Here's 90. Here's 38. We could find the next one because the triangles add up to 180 degrees, right? Talk to me. Let me go. Dynamic. We go figure it out. We have to do more. We're getting here. What's the answer? Give me the final answer. 50 how much? 52. Somebody second that. 52 is not the answer yet. That's MKL. 128 is right. 180 minus 128 will give you 52. Correct. So this what we found is this 52. That is this angle here we found, right? 52. Now, you remember the butterfly I was telling all about? Yeah. What's something? What's the butterfly, eh? Watch. Watch the butterfly, Watch it, right? Boom, bang. And let me just spot a line here. You see the butterfly there? What's the butterfly? Nah, well, it's a butterfly that's called it, right? They just call it bow tie sometimes, the bow tie theorem. Right? Everybody see the butterfly? Yes. No, because this is what we call this is angles in the same segment are equal. Right? Angles in the same segment are equal. So what this means is that this angle is equal to this angle. It will also mean that this angle on top here, this baby angle here, is equal to this angle here. You all see that? So all I simply put is angle MLG, or did they have it as JLM? I'm not sure. MLJ is equal to 52, and the reason would be angles in the same segment are equal, right? So watch it. MLG is equal to 52 degrees, well, therefore, MLJ is equal to 52 degrees, and the reason will be angles in the same segment are equal. Everybody good there? Angles in the same segment are equal. Once you see this being formed, this, right? Once this has been formed in a circle, I ain't sure too good there. This angle is equal to this angle. You all see that? Then this angle is equal to this angle. All 4 points must be touching the circumference. Are we clear? We good there? Yes. Write it down. So we're going to locate angle LJK. Cool? Let's go up. Angle L. Put on here. Right. Angle LJK, right? So follow it. Angle L to J to K. They want this bad boy up here. They actually have it here. So let me see how we find in this, right? What can we engage? If I have here as 52, let me raise it. If I have here as 52, right, my children? What will be this entire angle up here? If these two lines are equal. It's basically an isosceles triangle, right? Let me draw it on the side here. They're saying this angle is equal to this angle. Here's 52. What this angle will be here, my children? Same 52, agreed? And if this whole thing is 52, my children, and this part is 38, what will this little piece be? Huh? 52 minus 38. And if I find that, and this is a butterfly, and this is a butterfly, so this angle here will be equal to this angle here. So we're going to first find L, M, K, right? L to M to K. Follow me dot. L, M, K is what we're going to find, and that is simply 52 minus 38, right? There we go. I should first put that L, M, J is 52, eh? Watch it there. M, L, J is equal to 52. And the reason for that, you all can write it. Here was 52, right? Degrees. And the reason for that would be base angles in an isosceles triangle are equal, right? That's the first theorem we engaged, right? Then the next theorem would be, well, not theorem, that's just a law. Well, not term, it's a working. So to find L, M, K, it will be 52 minus 30. MLK. MLK would be equal to 52 minus 38, which is what? 14? Right? That's just a working. And the last thing now, hey, or the lock in. LJK would be equal to 40 degrees. And the reason for this would be angles in the same segment are equal. Boom, bang. Segments are equal. This is why I tell all you, when I see all in the corridor, Jesus knows how much I cannot understand. Well, let's get time for that, boy. What you call that memorize now, boy? How all I could be on the corridor, boy? When I see on the corridor, I start to sick, you know. Literally, you know. Right. So the next part of the question, I want me to find JHM, which is this angle on top here. Now there's a law which states that opposite angles in a cyclic quadrilateral add to 180 degrees. So let me show you what we're focusing on. We're focusing on... No. We're trying to find this angle up here. Watch it. Which is it 38? No. We're only using angle 52 here. Watch it. Look up when it's in red. You all see me cyclic quadrilateral there in red?
Yeah.
The opposite angles in that quadrilateral, that's four-sided figure because all the vertices, watch one, once all four sides are touching the circumference, the opposite angles in a cyclic quadrilateral add up to 180. So if I know that bad boy that is opposite to the angle we are trying to find, and I can find the angle, 180 minus 52 will give me JHM, right? Simple as that. So JHM is simply equal to 180 minus 52, which is, talk to me. 180 minus 52 was at 138? No, 128. 128, right? And the reason will be opposite right on. So you have to write the reasons for circle geometry. Opposite angles in a cyclic quadrilateral add up to how much degrees? 180. Boom, bam. You see, you very intelligent, eh? You sleeping on your intelligence, eh? All you. But let me tell you something. I understand how life is because I have been where you all are. I understood that I was not as bright as the other children in the class. You know what I used to flicking do? You know what I used to do? I used to eat, live, sleep, everything was my school. And I still come and fail Spanish. I failed Spanish and I got 3 in English. But I got a 1 in maths and I got a 1 in maths too. Maths was A, B, and C them days. GCE maths I did. I got an A in maths. This is how we analyze this thing, right? Let me watch what it have. What is in there? Everybody seen a butterfly there?
Yes.
Everybody see the butterfly, right? You all seen 2 quadrilateral, 2 cyclic quadrilateral. Quadrilaterals, right? Watch. Follow my dot. This is one. Boom, bang, bang, bang. That's one cyclic quadrilateral, right? Hold on, eh? So that's one. Look at next one here. You'll see that next cyclic quadrilateral here. So this what you're seeing here. Let me teach that out, please now. Let me teach that. You're seeing this here? It is a quadrilateral, yes, but it's not cyclic because this does not touch the circumference. Is everybody clear there?
Yes, sir.
Right. What else we have, boy? We know nothing else. So let me start to read. So they said the diagram below, not drawn to scale, shows a circle. The points P, Q, R, S, T, and V are on the circumference. Q, R, S, that's okay if that's out there. Q, R, S is a straight line. Right? Angle PRV, PVR, sorry, PVR 75. So what's something? Straight off the back. You see that 75 and this angle here? No. They are opposite angles in a cyclic quadrilateral. So they add up to what? 180. So you could find that, right? But let me go. They said this angle here is 60, right? Right. So that's all we have. That's all we know. No, let me see what they asked for. They said determine the value of each of the following angles, show detailed workings when necessary, and give a reason to support your answer. So we go for PTR. PTR. Tell me what else. That dog food. What's PTR? 75. Right? Why? Because what? What is now butterfly is our thing, what we calling it, but what's the theorem? What's the theorem? Segment angles in the same segment are equal. Let's go. Come on, let's write. Write on the. I want to write the theorems over and over. So this is equal to 75 degrees, right? And it'll be angles in the same segment are equal. Food. Right, let's go to the next part. Angle TPO. Let's locate TPO. That's TQ. TPQ, right? T to P to Q. T to P to Q. That's this bad boy they're looking for here. All right? Yeah. Now angles on a straight line add up to what? 180. So if he has 60, could we find this entire angle here? Let's call it QRT, right? So QRT, right? 180 minus 60 will give us QRT, right? So QRT is equal to 180 minus 60, which is what? 180 minus 60? 120. And the reason for this, the reason for this will be angles at a point on a straight line add up to 180 degrees. Everybody good there? So that's QRT, right? So watch it. I'm going to scroll up here now. Anyway, you all copy that down. Yeah, copy that down. So all we did was find QRT, right? Let me put it in. Here is 120 degrees. But are you all seeing the cyclic quadrilateral? Opposite angles in a cyclic quadrilateral add up to opposite angles in a cyclic quadrilateral add up to 180. So TPQ is equal to TPQ is equal to 180 subtract 120, which is 60 degrees. And the reason would be opposite angles in a cyclic quadrilateral add up to 180 degrees. Hey, all you know what's the funny thing, right? You know what's the funny thing about what's happening in the school system? All you know in 6 months' time, all it don't mean nothing. It's not all it don't mean nothing to us. But all it just be a memory. And we moving on to the next batch of students. That's the realest thing I can tell you right now. So like any kind of defiance all you might do, any kind of wasting time all you might do, right? It really don't matter to us. Because next year we rolling on to the next batch of students. I know I'm going to tell you, all they're going out there to face life. And some all they're going out there to face life with no passes. Nothing whatsoever. All you know how hard that is, right? So at least have a little paper in your hand, say, at least go a little KFC and work, right? KFC what passes now, no? And I can understand why. Because a student who don't have passes is a very lazy student, you know? All you understand that? A student that come out of here, spend 5 years and come out with nothing is a lazy child. Why were you in my establishment, right? Why were you by me? If you come here for 5 years, but you go be lazy fried chicken and all that, or ever going in some other enterprise, some other franchise land, what just stick the places be? Yeah. It's because they're lazy. They're lazy because all else have all the classroom just so. So you don't have to tell me you're lazy. Let me come out and have a ram over. I'm sorry for calling your name because you're plenty of lazy in this classroom. Plenty of them. Right? Let me go now. I want to finish this. Belly? Yeah. That'll mean nothing to me. There we go. So they want the obtuse angle POR, where O is the center of the circle, right? POR. Now point to note. They did not give us O here. So let me erase all this. Why that's called noise, right? I erase the noise. Right? And what's going on, my dog, boy? Oh, let's go mad in here. What's it? P to some O. That is not O up there, right? And then R.
So O comes from
right. So they said O is the center. It's not really an imaginary line. They gave us this, right? So watch this. Hey boy, how I'm missing that so way? Right, no, this is not it. They want us to find P to O to R, right? They want the obtuse angle, not the reflex angle. The obtuse is on this side, right? Now look at your theorem. So you'll see a theorem that states angle at the center. Now they said here's O, which is the center. So look at the term. It states that angle at the center is twice the angle at the circumference. You see? Check the terms. Check it quick. I'm going to draw the inside there. There's a term that looks like this. You have a circle. You have like this. Like boom, bang. And then you have an angle up here. You see that term? Angle at the center. Angle at the center. Here's 2. Let me call it x. And then up here will be x. You see that? You see that term? Angle at the center is twice the angle at the circumference. So this angle here is actually 2 times 75. Angle at the center is twice the angle at the circumference. So watch it. We're going to write it in last part for this question. Right? So obtuse angle POR is equal to 2 multiplied by 75, which is 150 degrees, right? Reason will be angle at the center, right? Excellent. Is center. Bell no ring. Emotional roller coaster. Angle at the center is twice the angle at the circumference. Everybody good there? I believe this is the last part of this question. Wait, what's that? Right. Close this. Yeah, I'll leave it for it. Right. I just want to make sure, right? This is angle of elevation. Right. Write this down. That's the end of our questions for this single period.